We are Group 8 for Senior Design 1 in the fall 2020 semester, and our project is to build a hybrid dual sport motorcycle. As for the team members, I'm Kyle Harkin.
Bshara Dababneh.
Joseph Vara.
Wilfredo Maldonado.
And Brian Vigilante.
And our advisors are Dr. Farahikia and Dr. Zunoubi. This is our display board, which you can find in Resnick Hall, and throughout the presentation we'll be going into more detail, everything you see here. So what is our project about? We're building a hybrid dual sport motorcycle. This is an example of a dual sport motorcycle, although not hybrid, constructed by KTM. So what is a hybrid dual sport motorcycle? What we mean by this is a dual sport motorcycle which is capable of both on-road and off-road transportation, and it's going to utilize both a conventional and a electric powertrain. So why is this important? Throughout our research, we found that across Asia, multiple countries are imposing legislation which will increase tax rates on motorcycles above 500 cubic centimeters, and therefore a hybrid option would be a great incentive, and not to mention the environmental benefits via this emissions reduction. So what have we accomplished so far? We're going to split it up into 3 categories: mechanical engineering, computer engineering, and electrical engineering. And I'm going to hand it off to the MEs to tell you about what they have accomplished.
So our chassis has had multiple iterations. Using FVA Analysis, the material and overall design of the chassis changed several times in order to find the balance between feasibility and cost. The maximum stress was 14.54 megapascals and the maximum deformation was 0.1148 millimeters. This helped us decide the type of material to use and for which design configuration would be best suited to handle the axial bending and torsional loads.
The final iteration for construction is decided to be built from Schedule 40 pipes made from AISI 1020 steel cold rolled. Although simple in nature for construction purposes, the final chassis will be able to handle all the loads applied to it. Furthermore, the FVA analysis of the frame proved vital to ensure the frame could handle the weight of the operator, engine, and electrical components without failing, and the final frame iteration will serve as the mounting platform for all the components. And now onto the computer engineering.
As we can see, we have the Arduino circuit where we use this voltage sensor as letter I. We use it to measure the grid plate speed. After that, we got to determine the motor RPMs, which stands for as revolutions per minute. We use that to determine the rotation speed of the wheels and to make sure the engine cylinders in the correct order. If we go in the upcoming few slides, we can show you how we use the physical circuits. As you can see here, we didn't do anything, just we see the steps as integer value, which is 0, and the revolutions per minute is just like 0.00. In the upcoming also few slides, we noticed how from different angles, it's the same pictures, but from different angles. And here we got 14 and 6 steps, and we ended up with the revolutions per minute as 3.00. This is what we have from the computer, and now we will give it over to the electrical.
Our motorcycle will feature an electric throttle instead of the conventional cable throttle system. The main battery pack will consist of lithium iron phosphate cells. The pack will be built in-house with a custom 3D printed polycarbonate enclosure. A low voltage battery pack will be used for the headlight and display in order to obtain more mileage from the main battery pack. A 3-phase brushless DC motor will be used to ensure consistent vehicle drive performance. The powertrain will be a series hybrid system as opposed to a parallel hybrid system. Some notable characteristics of this powertrain include its compatibility with smaller engine vehicles to meet power demands. Our team's plan for the spring 2021 semester is to finalize and construct the chassis, construct the mechanical and electrical powertrain, and implement microcontroller regulation of the entire vehicle. Thank you for watching our team's video.